Hello, fourth graders. Welcome to our Unit 4 review. We have learned a lot in this unit, especially a lot about multiplication. And so today we're going to be going over these items because our unit test is coming up soon. Remember, this is a great big long video with lots of questions, but the trade-off is that there is no math journal page at all. So this kind of takes the place of both of those assignments. So, first thing that we learned in this unit was what to do with these zeros. And if you remember correctly, when we have a problem that it has that are multiples of 10 or 100 or 1,000 or so on, we can cross off those zeros. We can multiply 4 times 3 and get 12. And then we can put back however many zeros are in the problem. So there's 2 zeros in the problem. So there's 2 zeros in our answer. Okay. How about this one right here? Let's see. 7 times 2 is 14. And then 1 0. And down here we have 9 times 6. Use that finger trick, right? 9 times 6. Or you can use a helper fact of 10 times 6, right? If 10 times 6 is 60, then 6 less would be 54. And how many zeros? 2 zeros. All right, you get a chance to do some over here on this side. So start with 80 times 90. Okay, 80 times 90. 8 times 9 is 72. I see 1, 2 zeros. 7,200. How about 50 times 60? Okay, these ones can be a little weird when you have something like this. Watch, because 5 times 6 is 30. Now, this 0 in this 30 doesn't count as one of the zeros that you add. It is the answer to the fact, right? So if you have 1, 2, 3 zeros now, you need to add 3 zeros. So you really have 4, but the first one is part of the answer to the fact. All right, last question is part F, 3,000 times 7. And you should have said 27,000. Excuse me, 21,000. I wrote it right, but didn't say it right. All right. Now, with our multiplication methods, when you are working on multiplication now, you can choose any method that you want to. Hey, whatever works for you. I'm going to bounce around into all the methods, but as you are what I want you to do is to kind of find the method that is working for you every time. Okay. So looking at 27 times 5, the rectangle method was the first that we learned. And if that one was working for you, then you might consider hanging with it, right? If you were always getting all the right answers and then you switch and now you're not, well, maybe switch back to that rectangle method because we did it first and we did it quite successfully. So in this method, I'm going to multiply 5 times 20 to get 100 and 5 times 7 to get 35. And then I just add those up. 100 plus 35 is 135. All right, your turn to do 43 times 6. All right, so you should have your answer keyed in here. We could do our partial products method with this. Now, if you didn't do partial products, that's fine. Remember, I'm going to start here with the 6, and the 6 gets to go twice, right? 6 times and 6 times. 6 times 3 and 6 times 40, not 4, right? That 4 is worth 40. 6 times 3 is 18, and 6 times 4 is 240. And we should have gotten 258. Now, if you did the rectangle method with this, those parts would have been the same. That's what I really like about how these two are connected. Okay. Now, if you did something else like the lattice method or a traditional method, if you got 258, then that method worked for you. If you just type something in a calculator, then that method doesn't work for you. Why does it not work? Because when we get to school, right, hopefully at some point, right, we want to be able to do all of these problems on our own, right? Because we're not going to be able to we have to be able to learn how to do it for ourselves, right? And so practicing and learning that is the best way. All right, two more longer multiplication problems. I'm going to take number 5 and you're going to take number 4. I'm going to use the rectangle method for number 5, but remember this rectangle almost looks like a square. Okay, and so the 42 I'm going to put on the top. So I'm going to chop off the 2, then leave the 40. And then over here, right, I need to chop off the 9 and the 30. So I have this rectangle method here. I'm going to do 40 times 30. What is 40 times 30? 1,200. And now I need to be careful that I multiply the right numbers. So 30 times 40 and 30 times 2. 40 times 9. What is 40 times 9? It is 360. And 2 times 9 is 18. So if I add these up, and this one is going to be one I need to write down, right? Carry the 1 and 1,638. All right, you get number 4, any method that you like, but make sure you are doing that problem. All right, let's see what you might have gotten. Oh, I haven't done lattice in a while. Lattice, not my favorite, but I know some of you like it. It's got a 1, a 6, an 8, and a 4 here, right? And so remember, corner, corner through, corner, corner through, corner, corner through. And we put the facts in. If you don't get your facts right, you won't get it right. And then remember, if I have 4, we have to put the 0 here to hold that place. Because if we put the 4 there, then that means 40. And when I add these up, I get 672. Not 8, 2. So if that answer matches your answer, great. If it doesn't, take a look at why. All right, now let's move on, right? We have liters and milliliters. Do you remember how many milliliters are in a liter? Milli means 1,000th, right? So there's 1,000 milliliters in a liter. Remember the video of the lady doing the drops, right? She did she had a milliliter dropper, and it would have taken her 1,000 drops to get into that, to get up to that, to fill that liter bottle. All right. So really, anytime we're changing liters into milliliters, it goes with times 1,000, which is why we did it in this unit, right? So times 1,000 times 1,000. We can put these in all these places if we want. And really, it works the same way, right? Cross off your zeros. Now, you can probably do this with less steps, but I want you to see that why it fits in this unit. Okay. How much would go in this this spot right there? 4 liters. 8,000 here. And what about this spot? Careful, not 1,600. Okay, if you have 3 zeros here, so 3 zeros, 16,000. You can't have 1,600 because we just said earlier that in 2 liters there were 2,000. So in 16 liters there can't be less than that, right? This number has to be more. All right, let's come down here and see what we did. Explain how you found how many milliliters are in 8 liters. Explain that for me. Yes, right. You should probably said I multiplied 8 times 1,000, or I took the 8 and added 3 zeros. Those all work. Grams and kilograms. Nicely done, right? Kilo means 1,000. So if milli means 1,000th, right? Things are getting smaller. Kilo means 1,000 is getting bigger. But either way, the conversion is times 1,000 again, right? So 1 kilogram equals 1,000. 3,000 grams equals 3 kilograms. What about 12? 12,000. What about 27? 27,000. Okay. I should write those down. 12,000, 27,000. And then I'm sure we know what we're going to write here on our test tomorrow. Explain how you did that. Same way that we did with the liters and the milliliters. All right, let's look at some word problems, right? We focused on using some of our multiplication skills in word problems. Here we have Caitlin, Michael, and Anthony drive together to visit their aunt and uncle. They decided to take turns driving. Caitlin drives for 24 miles. Michael drives 3 times as far as Caitlin. Then Anthony drives twice as far as Caitlin and Michael combined. How far did Anthony drive? All right, I want you to reread this question. Focus on getting that good visual picture in your head. All right, here we go. So, what I'm noticing, right? We need to notice everything here. They're going to their aunt's house. Our question is to find out how far Anthony drove. We know how far Caitlin drove, but we don't know how far Michael drove, and we definitely don't know how far Caitlin and Michael drove together. So, what do you think we should do first? Yeah, the key part with any type of word problem like this is to find a starting point. And we're going to be estimating. So if we know that Caitlin drove for 24 miles and Michael drove 3 times as far as Caitlin, right? We could estimate that 24. I'm going to make it 25 because 25s will be easy to deal with. I could have done it 20. And Michael drives 3 times as far as Caitlin. So to get Michael, this answer right here, let's see, I need to label it miles, and I'm going to label it as Michael. So that is how far Michael drove. Then Anthony drives twice as far as Caitlin and Michael combined. So if Caitlin drove 24 miles and Anthony and Michael, all these names, drove about 75. That's about 100. And Anthony drove twice, right? Times 2. So I'm going to estimate, this is my estimate, that Anthony drove about 200 miles. Okay, what did you notice that I did as I was estimating? Yeah, lots of like, oh, this is kind of close to this. And I think, this is around this, right? When we're estimating, that is the purpose of that estimating. Okay, so now our number models with our unknown, when we actually have to do this, we're going to have 24 times 3. And then we're going to, well, I guess we need to find that answer. Do I have space here? No, I don't. We'll need to do that on our scrap sheet of paper. 24 times 3. 3 times 4 is 12. 3 times 20 is 60. And that's 72. Okay, now you really have to know what these numbers are. 72 miles. 72 miles, what is that? I know it's a distance, but in the problem, 72 miles means what? Yeah, you have to stop as you're doing word problems like this every once in a while and make sure you know what your numbers are, right? I know that, and when I mean that, I know that you know that that's a 72, but 72, what does it represent? That is how much Michael drove, right? Michael. And Caitlin, what was her name? Is that her name, Caitlin? Yep. Caitlin drove 24. So now we need to do our next number model. We need to know how much they did combined. So we're going to add these two numbers. No carrying here, so I can figure out that that's 96 miles. 96 miles. This is Caitlin and Michael. And then Anthony drove twice as far as Caitlin and Michael combined. So, what problem are we going to need to do? We need to multiply 96 times 2. I'll let you do that. What is 96 times 2? 96 times 2. 2 times 6 is 12. 2 times 90 is 180. What is that? 192. 192 miles. That is our final answer, because that is how far we have figured out that Anthony drove. Well, look at this, right? Is our answer reasonable? Does it fit the question being asked? We want to make sure we reread that question, make sure we've answered the correct question. How far did Anthony drive? Anthony drove 192 miles, and it's really close. It's actually more closer than it usually would be. We're very close to our estimate. So what we would write is your answer reasonable? Yes, my answer is reasonable because it is close to my estimate and it answers the question. And you might be thinking to yourself, Mr. White, why are you always talking about answering the question? Of course, we're going to answer the question. You'd be surprised at how many students get to an answer, a number, and they don't know what that number means, right? Because they weren't thinking back about the question that was actually being asked. So I really am encouraging you to be a good thinker and reader. All right, last page of problems here, number 11. Another word problem here. Madison is buying a laptop for $586. He paid for the laptop using 4 $100 bills, 15 $10 bills, and 46 bills. How much did Madison pay? All right, you can figure that out. How much money does he have there? Right? It's not actually a very clear question. How much money did he pay? Well, he's going to pay that much, right? But I want you to tell me how much this amount of money, how much is that? Okay, this would be 400. 15 tens is 150, and 46 ones, you should have said $596. Okay, and those number models that I just drew here could be written right here also. So, and label $596. How much did Madison pay? Well, he paid $586, but he had $596. So I'm going to guess we have a change here. Question: did he pay the exact amount, too little, or too much? Yep, he has too much. And explain. You can do that. We know he has too much money because he needed, there's a dollar sign, $586, but has 596. You see how I wrote that as a complete sentence? I have a subject. My subject is we. My predicate, the rest of the sentence is my predicate, and I've told my reason why. All right, here we have last question, I believe. Yep, it is rectilinear figures. What do you remember? What do I need to do first? All right, first I am going to split this. Now, let me tell you how what I think might happen. If you split this here and here, you're actually making it hard on yourself, because now you have 1, 2, 3 rectangles that you have to figure out. If you can find a way to just split it into 2 rectangles, that's often the best, right? So now we have the baby pool and a very skinny pool for the grown-ups. Although I guess it's inches, so maybe these are a swimming pool for, I don't know, spiders. Do spiders swim? I don't know. Okay, and now we need to find the length and the width of each rectangle. Well, this one is probably the easier one. It is 4 long and 6 wide, right? So what is the area of that rectangle? It is 24 inches squared, and I'll be putting that in my answer there. 24 inches squared. What is the air? Ooh, look at this. So up here on the top, I have the length, which goes from all the way from here to here. Which number is the length? It is the number 14, right? Not the 5, not this 5. We don't need those right now. It's 14. And then obviously times 1, 14. What should I do with these two parts to get the answer? I need to add those up. And when I do so, I get my answer, 38. Now, the last thing, 38 square inches, which is right there, I need to also find is the perimeter. All right. So let me, you're probably going to, when you do this on your own, you're probably going to need to write down the different problems here and to draw the different shapes. Let's just try to make a new page so I don't have to erase all that. Here we go. Okay, so finding the perimeter, one thing that I'm noticing is that some of the sides aren't labeled. So when I'm going to find the perimeter, I need to make sure I label those sides by looking across. Now, when you find the perimeter, don't do this. Watch this. No, no, no. Okay. Now you can start this way. And in fact, you might, because you can cross out each number. I did a 5. I did a 6. I'm checking. I did 4, 6, 5, 1. Right. But don't try to add these up like this in one big stack. Break them into some smaller stacks. So I'm going to take these and these and these and add them together. Okay, so 14 plus 1 plus 5, that is 20. 6 plus 4 is 10, plus 6 more is 16. Those are 16. These are 6. And now I'm going to take my 3 answers here, 20, 16, and 6. Okay, what is the most common mistake is that people forget a number or they leave out a number and then they get stuck. All right, so our perimeter was 46 inches. All right, yep, that was a long video, but nothing else to do for your math journal today. Just a little bit of IXL for review. If you have any questions, be sure to reach out to me and let me know. Good luck.